Good morning, everybody. Myself, Mehul Batavia. I am coming from Institute of Engineering and Technology, Junagadh. I am HOD of the Electrical Department presently. In last lecture, we have learned about the AC fundamental, in which we study how the AC alternating quantity is generated. AC quantity is generated. Then the equation of the AC quantity, E is equal to Em sin omega t, or E is equal to Em sin theta, or we can say E is equal to Em sin 2 pi small t upon capital T. This is the different form of alternating quantities equation. Also, we learned about the waveform of AC quantity. This is same as sine wave. The waveform of alternating quantity is same as sine wave. Also, we learned about the RMS value and average value of alternating quantity, root mean square value and average value. Because the AC quantity has not constant value, but its magnitude is different as per time, from 0 to positive peak, then 0, then negative maximum value and 0. So for finding effective value, we learnt RMS value of the alternating quantity and average value of the alternating quantity. Also, we have learnt basic alternator, construction of basic alternator, and terms related to AC like cycle, time period, frequency, instantaneous value, peak value, etc. Now just we go for another some more information about the AC fundamental, and then we learned example for the same. Peak factor. Peak factor is the ratio of maximum value and RMS value. Peak factor is the ratio, and the ratio of maximum value of the alternating quantity to RMS value of the alternating quantity. The peak factor is equal to maximum value upon RMS value, that is equal to root 2. Phase of an alternating quantity is the time required to reach to certain value. It is expressed in second, radian or degree. Phase difference. In alternating quantity, phase difference is more important rather than the phase. The phase definition of phase difference is difference of phase angle between two alternating quantity. That is the difference of phase angle between two alternating quantity. It is called phase difference between two alternating quantity. And in AC fundamental, the phase value of the particular AC quantity is not more important, but phase difference between two different alternating quantity is more important. Value of two different alternating quantities become maximum at the same time in the same direction, then they both are called in phase quantity. Just we see here for more information. See here. Let us take example for phase. This is one alternating quantity. Suppose at position A, the phase of this alternating quantity at position A is pi by 2, or we can say suppose this is time period. આ time period છે, તો at A phase value જે છે એ t by 4 કહી શકાય. Either t by 4 in second, pi by 2 in radian. We can express phase value in both way, in second t by 4 and in radian pi by 2. Also the phase of this alternating quantity at B position, at position B, the phase of this particular alternating quantity at B 2 pi, or we can say t second, or in radian 2 pi, or in second t. મતલબ કે ફેઝ જે છે તે અલ્ટરનેટિંગ ક્વોન્ટિટીનો શું દર્શાવે છે? સમય દર્શાવે છે કે કઈ વેલ્યુ, કોઈ પણ વેલ્યુ કયા સમયે પહોંચે છે. હવે ફેઝ ડિફરન્સ, સપોઝ આ એક અલ્ટરનેટિંગ ક્વોન્ટિટી છે EA, સપોઝ આ EB છે, EB ઇઝ ઇક્વલ ટુ EBM સાઇન ઓમેગા ટી. સપોઝ EB એક અલ્ટરનેટિંગ ક્વોન્ટિટી છે, EMF છે, જેને આપણે EBM સાઇન ઓમેગા ટી વડે રિપ્રેઝન્ટ કરશું. હવે સપોઝ બીજી એક અલ્ટરનેટિંગ ક્વોન્ટિટી છે, અલ્ટરનેટિંગ EMF છે EA. આ EA છે, EA ઇઝ ઇક્વલ ટુ EAA સાઇન ઓમેગા ટી પ્લસ 5. આ એંગલ 5 છે. EA અને EB વચ્ચે ફેઝ ડિફરન્સ જે છે એ 5 એંગલનો છે. સપોઝ EB ને આપણે રેફરન્સ તરીકે લઈએ, EB અલ્ટરનેટિંગ ક્વોન્ટિટી છે, EMF EB છે, એને જો રેફરન્સ તરીકે લઈએ તો EA ને આપણે EMA સાઇન ઓમેગા ટી પ્લસ 5 વડે રિપ્રેઝન્ટ કરી શકશું, ઓમેગા ટી પ્લસ 5. હવે સપોઝ બીજી એક ત્રીજી અલ્ટરનેટિંગ ક્વોન્ટિટી છે, થર્ડ વન, EB પછી 5 થીટા એંગલે સ્ટાર્ટ થાય છે. આ ફેઝ એંગલ થીટા છે. EC ઇઝ ઇક્વલ ટુ ECM સાઇન ઓમેગા ટી માઇનસ થીટા. અહીંયા EB જો રેફરન્સ તરીકે લેવામાં આવે તો EC જે છે તે થીટા ડિગ્રી લેગ બિહાઇન્ડ છે, જ્યારે EA EB કરતાં 5 ડિગ્રી લીડ છે. મતલબ કે EA ઇઝ લીડ EB બાય એંગલ 5 ડિગ્રી and EC is a leg behind EB by theta degree. અહીંયા થીટા અને 5 ફેઝ ડિફરન્સ છે, થીટા અને 5 ફેઝ ડિફરન્સ છે. ફેઝ 5 છે તે EB અને EA વચ્ચેનો ફેઝ ડિફરન્સ છે, અને થીટા છે તે EC અને EB વચ્ચેનો ફેઝ ડિફરન્સ છે. Let us see here phase difference at 30 degree. Just see slide. We see slide. Phase difference of 30 degree. So second picture is in phase, and third figure is shows phase opposition. Here in first figure, phase difference of 30 degree, voltage and current, alternating voltage and alternating current waveform having a phase difference of 30 degree. Here the voltage waveform having a take as a reference, and current is lag behind 30 degree with respect to voltage. And in figure of in phase, voltage and current having a zero value, maximum value at the same time, so called in phase quantity. In figure number 2, voltage and current both having a maximum value at the same time. So it is called in phase quantity. આ વોલ્ટેજ અને કરંટ બંને ક્વોન્ટિટી જે છે તે એક જ સમયે મેક્સિમમ થાય છે અને એક જ સમયે ઝીરો થાય છે. તો એવી ક્વોન્ટિટીને આપણે ઇન ફેઝ ક્વોન્ટિટી કહેશું. બંનેની મેક્સિમમ વેલ્યુમાં ડિફરન્સ હશે. વોલ્ટેજ અને કરંટની મેક્સિમમ વેલ્યુ ડિફરન્ટ હોઈ શકે, પરંતુ મેક્સિમમ વેલ્યુ એટ એ ટાઈમ એટેન્ડ થાય છે, તેથી તેને આપણે ઇન ફેઝ ક્વોન્ટિટી કહી શકશું. ફેઝ ઓપોઝિશન, થર્ડ ફિગર, we can see the alternating quantity A and alternating quantity B having a phase opposition, मतलब કે 180 ડિગ્રી ફેઝ ડિફરન્સ છે. જ્યારે એ ક્વોન્ટિટી મેક્સિમમ હોય છે, પોઝિટિવ મેક્સિમમ, ત્યારે બી ક્વોન્ટિટી નેગેટિવ મેક્સિમમ હોય છે. ફિગર નંબર 3માં આપણે જોઈ શકીશું ફેઝ ઓપોઝિશન ફિગરની અંદર કે એ ક્વોન્ટિટી મેક્સિમમ થાય છે, પોઝિટિવ મેક્સિમમ, એટ ધેટ ટાઈમ B attained maximum value but in the negative direction. Further both attained zero value, and next cycle B attained maximum value in positive direction but at that time alternating quantity A attained maximum value in negative direction. So we see the 180 degree phase opposition between A and B alternating quantity. Different forms of alternating EMF and current. We learnt about this in last lecture, but we have to revise this equation because we just start example. So before solving example, our mind should be clear about the equation. We can write the equation in different form. Small e is equal to Em sin omega t, or we can write Em sin theta. Also we put the value of theta is equal to 2 pi f t and put the value of f is equal to 1 upon t. So we can write also EMF equation E is equal to Em sin 2 pi t upon t. Similarly we can write alternating current equation in following way. Small I is equal to Im sin omega t, Im sin theta, Im sin 2 pi f t and Im sin 2 pi t upon capital T. That capital T is time period. Now we start example. Example number 1. An alternating EMF is represented by small e is equal to 200 sin 2 pi 50 t. Find maximum value, frequency, time period and angular frequency omega. Solution. Small e is equal to 200 sin 2 pi 50 t. Now we have to compare this equation with standard equation. We know small e is equal to Em sin 2 pi t, 2 pi f t. So we compare this equation with the given equation. So we get maximum value capital Em is equal to 200 volt very easily. We can also find out frequency with comparing this equation, both equation. Frequency is small f is equal to 50 Hz. And time period, that is capital T is equal to 1 upon f. So 1 upon 50 is equal to 0.02 second. Angular frequency omega is equal to 2 pi f. So omega is equal to 2 into pi into 50. So we get 314.2 radian per second. That is final answer of omega angular frequency. Example number 2. An alternating current is represented as I is equal to 40 sin 2 pi t upon 0.02. Find maximum value of current, time period, frequency, value of current at 0.04 second and time required to reach to positive 10 ampere for the first time from 0. I is equal to 40 sin 2 pi t upon 0.02. Comparing this equation with our standard equation, I is equal to Im sin 2 pi small t upon capital T. From this comparison, we can easily find out IM, maximum value of current, is equal to 40 ampere, 40 ampere. Time period, we can also find out very easily. Capital T is equal to 0.02 second. Frequency F is equal to 1 upon T, that is equal to 1 upon 0.02, that is equal to 50 Hertz. Now I is equal to 40 sin 2 pi T upon 0.02, and we have to find out the value of current at T is equal to 0.004 second. मतलब કે 0.004 સેકન્ડ ની પછી કરંટની વેલ્યુ કેટલી છે? I have to put the value of small t into standard equation. I is equal to 40 sin 2 pi into 0.004 divided by 0.02. Here we put the value of small t is equal to 0.004 into the equation. So we get sin 1.2566. So by use of scientific calculator, we can find out the value of I current is equal to 38.04 ampere. Or converting the radian mode into degree mode, so we have to multiply and dividing the angle 1.2566 into pi 180 upon pi, so we get 71.99 degree. Put this value into equation. So we can solve this example by radian mode and as well as degree mode. So I is equal to 0.38.04 ampere. Now keeping radian mode on calculator, we get time t is equal now we find out value of current 10 ampere at how much time, मतलब કે કેટલા ટાઈમ પછી આ અલ્ટરનેટિંગ